Astronomy before the telescope. This talk is also included in the HR2 section of Marcel Grossmann 17 meeting, the section dedicated to the historical supernovae. It is simple why this topic is treated in the middle of historical supernovae parallel section, because all the historical supernova occurred before the invention of the telescope. The supernova of 1006, the supernova of Lupus, was observed in Switzerland in the monastery of St. Gallen in the night of 30th of July of the year 1006. It was the brightest because it was very low in the southern horizon, and it was possible to read a paper in its light. The supernova of 1054, the one of Chinese, is called the supernova of Chinese, even if we said the accounts of American Indians and European observers. This supernova was well before the invention of the telescope, but occurred when let's say professional astronomers, duty scientists, or today we would say, were active in China for the emperor. The supernova of Tycho Brahe is the one of 1572, was studied and described and measured its position by the Danish astronomer Tycho Brahe since the 11th of November 1572. Few years later, the supernova of Kepler and Galileo appeared only 3 years after the death, untimely, of Tycho Brahe on 24th of October 1601. The supernova appeared in the 9th of October 1604 in the foot of Serpentarius, the Ophiuchus constellation. Kepler studied it, gathered the observations, and proposed an origin for this phenomenon, the conjunction of the triple conjunction between Jupiter, Saturn, and Mars occurred the day before. So this hypothesis, which was again represented in 1614 during in the text dedicated to the birth of Jesus, the datation of the birth of Jesus. Again, Kepler calculated that there was a triple conjunction between Jupiter and Saturn, and this event produced something new, exactly like the phenomenon of 1604. That's why the hypothesis of the supernova has been mentioned about the so-called Star of Bethlehem. The hypothesis of Kepler is that the supernova was produced by the conjunction. Closing this parenthesis, Kepler studied also the chronology of the birth of Jesus, demonstrating that he was born after the death of the king of Judea, Herod. Why? Because in Joseph Flavius it was mentioned a lunar eclipse, a total lunar eclipse occurred during Easter, and it was the 4 before Christ, the year 4 before Christian era. So it was confirmed the fact that Jesus had at least 2 years, he was at least 2 years old in 4 before Christ, and that's why Kepler get the time of the triple conjunction of Jupiter. Other supernovae, the one of Cassiopeia was mentioned probably by John Flamsteed around 1680, but probably it was a dusty supernova, so it was not an evident phenomenon for that time. The remnant has been discovered in radio waves, and it is one of the well-known supernova remnant of our galaxy. And finally, S. Andromeda, discovered in August 1885 at the telescope, was the object who drew the astronomers later in understanding that it was not a normal nova, but it was 10 magnitude brighter, so a supernova, as the people of 1930s like Walter Bade could define. Astronomy Before the Telescope is also a title of a famous book, here is the link, that I read for the first time in Pescara, because I bought it in a library that is no more existent in Piazza del Sacro Cuore, just in front of the Igranet Center, toward the sea side. The book is a very inspiring text, and I recommend to read it to everyone. The position of the stars, the scope of Chinese astronomers was to alert the emperor of every new thing in the sky, and to say that it was necessary to know the sky. And now we have, since more than 100 years, the Convention of International Astronomical Union of 88 constellations. This number was not always the same. At the time of Ptolemy, about the half of the constellations were known or used, and many of them were gathered in a single one. For example, in this image of Atlante Farnese, who is a statue which was in Rome, in the Caracalla Terms, and afterwards in the Farnese Palace. Now is in Naples, because the collection of Farnese, because of weddings, royal weddings, was transferred to the city of Naples, and is now in the National Archaeological Museum. In this sphere over the giant Atlas is represented the Argo ship that, after Lacaille, was divided into several constellations: Vela, Puppis, Pyxis, and so on. Many instruments also populated the southern sky in order to make possible the localization of the stars, of the astronomical events, which were studied in greater and greater detail. So I would recall that originally in ancient times the coordinates were used. Ptolemy is the first in its geography to introduce the coordinates of the cities, But there were also narrative maps, narrative in the sense of this city is after this other one along this path. This is the most famous Roman map. It is a copy of 13th century. It's called the Peutingerian map. And here is represented Rome with the Claudius harbor that now is nowadays is under the Fiumicino International Airport. And this is the street leading to Rome, the famous proverb. This is the river Tiber with the affluents. This is the Apennine range that is just schematized, and Abruzzo is over here. Pinna is Penne. Pescara was around this position near the river that nowadays is called Pescara. Here you can recognize Ortona and Lanciano. So this is the Abruzzo coast. This is the Marrucini city, Teate here, which is Chieti. So this is the area where we are celebrating the 17th Marcel Grossmann meeting. This is the way to represent the position in a narrative map, and analogously a narrative map was the sky. That's why the position of the star in a map were very, very late with the precision that we know nowadays. So in the catalog of Ptolemy there is mentioned the magnitude of a star and the position of a star, but the map of the star was not transmitted. Only the instruction to create a map were transmitted in the manuscripts. So I took the example that I studied deeply in the past, the first variable star recognized, Mira Ceti, that was present in the catalog of Ptolemy, because the star was mentioned as the one Epites Lophias over the whale's fin. Lophias is fin and whale is not mentioned, but it's the word kaitos in Greek, cetus in Latin. Bayer made the first stellar maps very well used, the Uranometria. There were other stellar maps with coordinates before, the one of Paolo Toscanelli with the Halley's Comet in 1456, or afterwards the one of Jean Flamsteed, the Atlas Celestis, published posthumously in 1755, and the French map of Philippe de la Hire of the Observatory of Paris in 1701 with the coordinates of the stars. Flamsteed published like 3,000 stars, and de la Hire more than 1,000 stars. This is the Bull constellation, the Taurus, made by Johannes Bayer, a lawyer in Nuremberg, that realized the Uranometria, which in Latin and Greek means measure of the heavens, of the sky. This star is the star near the Crab Nebula, discovered by John Davis in 1731 and represented in the Uranometria Britannica published in 1750. Here each square is a degree, a single degree. This is the ecliptic, and this is the 10th degrees of you see here 0 or 30, after there is the number 5, the 10, 15, 20, 20th degree of Gemini, even if the constellation is the Taurus, because of the precession of the equinoxes, the sign of Gemini, which is the after the equinox, the second one, there is the equinox in Aries, 30 degrees. After 30 degrees in Aries, there is the Taurus. 60 degrees starts Gemini, and 90 degrees from the equinox, there is the solstice. So we are near the solstice, because the solstice is just out left, like here, with the degree number 30 of Gemini, which is exactly the position of the solstice in the sign of Cancer, but in the constellation of Gemini. In 1054, the Sun was in conjunction with the Crab on 2nd of June, and the Crab was in the 11th degree of Gemini. In 1750 it was like here in 20th degree. Nowadays we would have the same map with the Crab in 24.5 degrees of Gemini. This ecliptic would move on the left, on the right side. This is the precession of the equinox. So the coordinate change of 1 degree in about 70 years, and Galileo used the tool of landscape to measure the solstice, the summer solstice, when the sun was approaching a cape in the sea landscape, and so could know when the solstice was occurring. We can also do that among the houses of our cities, because looking the landscape, the skyline that we have in front of us, from the same point we can see easily the different position where the sun sets along the year. The stars set always in the same position, at least in a few years. For example, if we consider 2 years of time, the difference of the position of the stars with respect to the landscape cannot be larger than 2 arc minutes. And since the supernova was the supernova of Chinese 1054 was observed for 650 days, so about 2 years. Even if the Chinese were speaking about the single star, the star named Tianguan, the Zeta Tauri, and the distance measured in digit in some of the accounts, the position during these 2 years did not change for more than 2 arc minutes, that are well below the possible resolution, even using the landscape tool. Landscapes astronomy was a teaching of the architect Francesco Giannini, an IGRANET fellow from Chieti, that taught us many examples of this kind of astronomy. In the names of some locations are reminded to us, hidden in the ripples of history, and of anthropology, the astronomical characteristics of some place. Caprafigo, for example, there are two places where this name is mentioned, are places where the winter solstice was observed, so the sunset at winter solstice coinciding with the sunset of two constellations, the Capricornus and the Ophiuchus, or the Gran Sasso, the mountain, which was related to the sunset in particular days that in Latin culture were dedicated to Jupiter, and in the Christian culture to Saint John the Baptist, when the sun was like beheaded, like Saint John the Baptist, at its sunset by the form of the mountain as seen from a single point like Chieti. The confusion limit is also another thing to be considered in the account of Chinese, because the supernova was observed since its brightest display, but after 2 years the star was so faint that it was confused with the other star around it. So, is the time of last vision of the supernova exactly correspondent to the last visibility to the naked eye, so fifth magnitude or sixth magnitude, apparent magnitude? The answer may be not, because in a crowded field of view, field of stars, star fields, it is possibly invisible or indistinguishable a star from the other ones. So maybe the estimating the end of the visibility with the sixth magnitude is, or maybe an underestimate. The confusion limit could anticipate the last vision, the last account of vision of the supernova in 1054, so 970 years ago. Finally, the resolution of an image. So we wanted to study the visibility of the lunar spots. They are visible, they are well known, but we asked to ourselves why they were not named with different names. Here, for example, we can see the visibility of Chryses, the Mare Crisium, or the three Serenity, Tranquility, and Fecundity sea on the moon. Why they have not been named before the telescope, even if they are visible, or the Oceanus Procellarum, the ocean of the tempests, and then Oceanus Tempestatis, Oceanus Procellarum in Latin. The answer remains mysterious, but we did a series of experiments asking the people to draw what they would see by naked eye, and they draw things that are identifiable with feature on the moon. So in principle the some arc minutes were the limits available to the naked eye also on the moon. Here there is my thesis student that made this drawing for us, and we thank her, and we thank many participants to this project. Conclusions. Naked eye astronomy involves space and imaging resolution, contrast resolution. The moon is better visible during the afternoon or during the morning. with respect to the night time, where the luminosity is too bright to detect the thinner albedo maps. Confusion limit when there are many stars in the Milky Way. It is difficult to say when the star disappeared, the supernova. Transcription standards. In a culture where the coordinates were not yet belonging to the people, the description of the phenomenon was satisfactory even to, let's say, professional or scientific standards, like in China for the emperor office, astronomical office, and the landscapes astronomy recall to us that the stars are setting and rising always from the same point of the horizon, at least within a few years of time span. I thank you all for your kind attention.